chain rule is the most important rule. I'm sorry. Got it now? All right. So what is chain rule? The best way to describe chain rule is this way. If I ever take a derivative a composite function, now do you see that there is a outer function? So this is the outer. And this is the inner. So there is an outer function and inner function. If that ever happened, I call it the onion rule. Like you're peeling the onions. When you take a derivative of the onion, take a derivative like you're peeling. You peel the outside layer, the inside layer is still intact. It still keep it inside. And then you're going to multiply by the derivative of the inside layer. So basically, it's going to be f prime of g of x times the g prime of x. And that's it. That's the rule. Super easy, but it can be confusing. Right? Also, sometimes people think of like is like kind of like general power rule, but we're going to talk about that in a second. Well, there's two guys not in the beach.
Huh?
I said there's two guys not in the beach.
I know my car broke down, so it's not like I could have gone anywhere.
Your car's what?
My car broke down, so I couldn't go anywhere.
Your car broke down? Everything okay?
But like I would never see a reflection see it. You know?
I appreciate it.
Like, I would show up and then leave.
I appreciate it.
That's it. Okay, sure.
You did show up, so.
Chain rule. So.
All right. So then, f prime of g of x times g prime x. Now, to take a derivative of this function is super easy. Imagine before you have a x squared plus 1 to the third power. And if I say I want to take a derivative of x here, so the way to think about it, there are two layers. This is the first layer, and this is the second layer. So let's take a derivative of the first layer. The first layer is going to be 3 times x squared plus 1 to the square. Why? Because I just imagine that this is a big, huge x, right? If I take a derivative of x cubed, what will happen? The 3 drop in the front, it becomes 2, becomes 3x squared, right? But the inside the onion is still there. Now I'm going to take a derivative of the inside the onion, which is going to be 2x. Does that make sense? So that's going to be 6x times x squared plus 1 to the 2. Now, the 6x cannot distribute to the parentheses because that's different power. The argument's different there. You cannot distribute inside. You're going to keep the answer like that. It's that easy. And that's chain rule. You want to try it? Okay. Y equal to 3x minus 2x. Sorry, my handwriting's really bad. To the third power. Let's take a derivative of this. So who take care of the score, Damien?
Huh? My mom.
Oh, I thought she had to work.
She doesn't have to do.
When are you gonna get your car fixed?
Tomorrow.
What's wrong with it?
What did they got recalled for camera sensitive? Like the back camera? Just what year is your car again? I'll get the car. I'm from Cali in different days. I'll get the car.
He's a Uber driver is gonna report him.
Hey, Uber Black since they're no regular Uber. You want to delete that on Joe?
The Uber driver is gonna deport you.
Yeah, I would make sure he gets deported. Make sure as you're getting deported. We are getting deported. I'm Puerto Rican selecting. Like that.
Do you guys finish?
Sir.
Did? Is it hard? Just take a derivative of the first layer, which is something extra there, right? So y prime is going to be 3 times, this one is going to be 3x minus 2x squared. And then to the second. But I haven't taken derivative of the inside yet. I had to take a derivative of the inside, which is going to be 3 minus 4x. Now, can those distribute? No, because they're different power. This is to the first power and distribute. But this 3 can distribute that, so that's going to give you 9 minus 12x. You don't have to, but it's 3x minus 2x squared to the square. You can distribute to the first power. You cannot distribute to the second power. Is that okay? Now, what about derivative of this? So this is 1 over cube root of 2 minus 4x squared.
Two minus 4 squared to the square.
You got to think about algebra rules.
The exponent attached to the x is
Square. Alright, did you guys got it? So I'm gonna use the algebra stuff more than I use calculus. So what I mean by that is a to the negative n equal to 1 over a to the n. That's first one. The second rule is a to the m over n equal to a to the m over n like this. This is from algebra, right? So can I rewrite this into 1 over 2 minus 4x to the 2/3? Is that okay? And can I rewrite this as f of x equal to 2 minus 4x squared? Sorry, I'm missing the square to the negative 2/3. So I just rewrite this. I didn't even do calculus. I just rewrite this in term of algebra, and that's it. I haven't taken derivative yet. If I take a derivative, what will happen? This is going to be the first layer. This is the second layer. Is that okay?
Right.
So it's going to be negative 3. And then what's the derivative of negative 2/3? It's going to be negative 5/3, right? Times negative ax. Is that okay? That's the derivative. You can simplify this by saying 16x over 3 times 2 minus 4x to the negative 5/3. Or you can write down 16x over 3 times 2 minus 4x to the 5/3. Did you guys get it? Was it hard or no?
Not that hard. It was so. Medium, yeah. Medium.
You want to try again?
Oh,
I mean, I can say g of x is equal to negative 7 over 2x minus 3 to the 4th power. So it's fairly easy as well. It doesn't take long to do chain rule. The problem is when the combination of chain rule and other rules, that's where you have issues. I got this. You got that? Got it? Same thing. There goes chain rule. How much time I have?
2 minutes.
Now I want to talk about three situations you should avoid quotient rule. So this is it's not part of chain rule, but it's 3 situations you should avoid quotient rule. The first situation is a monomial on the bottom. You should always split. So for example, x squared minus 2x minus 1 over square root of x. What are you supposed to do? Should you do quotient rule? No. Second is constant on top. So this time it's constant on the top, remember? Should you use quotient rule? No. So So let's just say 1 over x minus 1. The best way is to change this to x minus 1 to the negative 1. So if I take a derivative of that, it's going to give you d to the dx of x minus 1 to the negative 1. That'd be negative 1 x minus 1 to the negative 2 times 1. So that's negative 1 over x minus 1 squared. The third situation is constant on the bottom. So let's say 2x minus 1 to the square over 2. I don't take a derivative using quotient rule because I can just look at 1/2 of 2x minus 1 to the square. I can do a chain rule. So second and third situation use a chain rule. Today's homework should be fairly easy. So, Aiden, what's his phone number? Let me call him. And call him, I'm gonna call him because my phone number looks like a scam. My phone number literally is like 321-438-0000. And people don't answer the phone because they're like, this looks like a scam phone number.
I'll see you after school. Bye bye. I say I don't know if they was senior skip day. I was skipped. And I'll also make a WhatsApp group chat like around that time too. Alright. He's out, bro. Oh, you're gonna call him now?
Yeah.
He might be in a meeting, but
You might be a meeting.
yeah. That's my rival, Mr. Yeah.
That's your rival.
Yeah.
He's gonna do better than you.
Why are you hating for no reason? I was here on the longer time than they want.
Mr. Ray, can you post the homework during or before lunch so we can come after? Thank you. Bye, Mr. Ray.
Bye. You still owe me a quiz.
And
You still owe me a quiz.
All right, I'll probably.
Can not log in.
and they pulled up the school. And you're not skipping? No. Why? You know,
Aiden's not senior. Aiden's sophomore.
I need totally fantasy. Probably more. That's their homework?
Huh?
That's the homework I'm going to bed evening night. By 10 p.m. I'm going to bed.
You're not going to bed. Bro, why is she your homework?
She's a senior. She's skipped. Wait, you're a senior. You didn't want to skip? What
What's that? What do you mean you showed up, bro?
I thought you were gonna be one.
I didn't know it's nice senior skip, bro.
He called his mom. He's like, it's your birthday. He called her. I was like,
I'm glad to hear. You doing good?
We're the
I'm
lady
doing
here.
all right.
Where's your girlfriend?
Oh, she's sick. Whose
She's skipping. She don't look like a skipping type.
No, she wouldn't. She.
Amelia looks like a skipping type.
Oh, Amelia.
Was she not here either?
Yeah.
But yeah, no, Josie literally, she woke up this morning with a horrible headache. I can't. We are on. I had one piece of paper left. I had to make everything fit.
You did all your homework on one piece of paper?
Yeah, like you did. I just I was gonna skip dick, but I was like, what am I gonna do at home? Nothing. Like I'm
Go to
just,
the beach.
That's what my mom.
I'm gonna
said.
sit
What
on my
are you
ass
doing?
and do nothing. No, it's like
Oh, you get more
Same line
people find.
I was like far afraid that's right. Like I might as well be here. Evil. Otherwise, I'm just gonna sit in my room, just like stare at the wall.
And I can't